Hi there. Uh, Hello. So this is my project. This is my first Dapp. You can say this is my first Dapp that I built. This is actually a to-do Dapp where you can add a to-do, toggle the value to done or not done, and you can filter all your to-dos. It means that all the to-dos that you added on the blockchain, it will get filtered, because as you can see, there are a lot of to-dos over here, and not all of them are my to-dos because I've not added all of them. So let's say I click on filter your to-do. It will actually show all the to-dos that I added using my this address. So it actually uses the address that you have used to add this to do, and filters it out using filter method from an array. So if let's try adding it to do. So I'll add this to do, and I have not filled the name here, so I'll again fill something like Harish over here. So it's optional, you can either type your name or maybe not, but this has to be something. So I will confirm the transaction, and it will take at max 15 seconds to get added. And as soon as it gets added on the blockchain, it will also appear over here. And it is actually deploying on the test network and not on the mainnet, because obviously you will have to pay real gas fee for doing so. And it's not a very it's not gas fees on Ethereum are not cheap. So like you can we use test networks for that purpose. So I'll refresh it, and as soon as refresh, you can see my to do has been added. Actually, even without refreshing, this to do should appear here. It was appearing, but I don't know what happened. I'll check the code after this tutorial and fix it. But yeah, this is a to do, and I can toggle the value to done. So for that also I'll have to pay some gas fee, and I'll pay the gas fee, and I'll confirm, and it will mark the to do to done. And I can also filter the to dos as I told. So I'll show you how to do that too. Just will wait a second. So yeah. Okay, so this, as you see, we didn't require we didn't require we didn't have to refresh this page in order to see this. It actually rendered it without having to refresh because we are using React. So I can filter it, and it will filter all the to-dos. If I change the address, it will filter the to-dos from that address as well. So I'll just refresh it and filter your to-dos, and yeah, there we go. Uh, so as you can see, there are a lot of to-dos. As soon as I click on filter, there are less of them. So now let me show you the code. So uh, just a second, I'll change the workspace default purpose. Yeah, here it is. So this is the code for this is the solidity smart contract for our to do that, and I'll explain it to you. And if you don't know what a smart contract is, you probably should Google it out, or maybe just I can explain it, and I'll try to explain it in short. What basically a smart contract is a smart contract is actually a piece of code that runs on the EVM, and EVM is Ethereum virtual machine that the nodes have, that the nodes or miners you can call them, that they run this node on their computer, and the compiled bytecode from the solidity is actually runs on that EVM and does all the processing part of it. So yeah, this contract, you can think it like this contract is gonna run on multiple nodes or multiple computers, all those computers that are deployed on the blockchain. All those computers that are connected to the blockchain, to the EVM or to the Ethereum blockchain. So yeah, so a contract is you can compare a contract to you can like a contract is like kind of similar to classes in Java or any other language. So we have a to-do contract. Before writing the contract, we actually define the compiler version that we are using, and even before that, we have to write this line, uh, otherwise it might throw us some error. So yeah, this is the contract. The contract name is to do, and we have a struct named task, and we have all this property, all this data, all this like units and addresses and all this required data variables. So we have all these variables over here, and we have a task array. We have an array of struct task. So it's actually an array of task, which means task is a struct, so it's an array of this task struct, and it's called tasks. And then what's you might ask what this public means. This public just means that this function, this task, it actually can be called anywhere, even from outside the contract, even from inside the contract, even from a different contract, anywhere. And it's public. It basically means it's public and it can be called from anywhere. So now we have a function we named create task, and we are taking in a string, which is our content, which is our to do, and as well as the author name. And it's an external, so you can kind of compare it to like public and external are kind of similar, but only difference is that external external if you use this external, we can't run a function inside. Like I can't run this create task inside another function because it's only external. So you can understand it like that. So now we have address. Address is a special type of data type in Solidity, where you have a hexadecimal 64 64-bit address. So now you have message.sender is actually uh, it's actually the address of the address of the person or who's gonna call this function. So let's say if I call this function, it means that I am creating a task. I'm adding a task, and if I'm adding a task, this message of sender will be equal to the address from which I'm going to deploy. So in my case, when I deployed, it was this. So it's this message dot sender over here, and then we have a get task. It will actually return us the task of particular ID. So we have ID. We can get a task of particular ID using it. So if we gonna return all these values, task ID dot author, done all this from this struct. Then we have a function get task, which will return us an array of the task struct. So this is a task. This will return an array. So of struct task. So we have returned. We have to write this over here. What it's gonna return. So I wrote returns task task array, and memory is a keyword. It means that we don't need to save this thing in our contract. It's kind of, you can think it like it's gonna be used in the RAM, or maybe not in the storage. Actually, it's gonna be saved in the used in the RAM. So now we have a function set done true, which will actually toggle the value to toggle the done value to true, or maybe false if it's true. So what I've done is you have this argument, which is id index, and this function is also external, and we have an address of writer, which is actually so now we gave a writer as the message of sender, which will call this function. So let's say I want to toggle this particular task. So it will take my address and save it into writer, and then it will require certain conditions. So if this condition requires, if this is true, then only it's gonna run the code below it. So if this is true, it's gonna run the code below it. If it's not, it's gonna revert the transaction, or maybe it's gonna not run this thing over here. So we have this condition as the address of the address of this task that you wanna change, the, the address from which it was deployed. So it was saved over here in the writer. So we have a writer data type is in task. So we took that from array to task, index, and dot writer. It should be equal to the writer, which is the person who's gonna call this particular function. So function call a function. It's actually nothing, just a function that will give me the return me the message dot sender value, and yeah, it will actually just return me the address, my address, and nothing. It's just for test. You can ignore this. It's not even required. Only it's from here to here. That's the important part of the code, and it's very short. You can say it's just 20-25 lines of code that is just gonna get deployed. So what we do after this is what we compile this. We go to compile. We compile this, or in my case it's auto compile, so it's gonna automatically compile. Then I'll deploy it using injected Web3, which means I'm going to use MetaMask to deploy. Click on the deploy and pay the gas fee, it will get deployed. And then the second part comes where we have to use actually we will have to use okay, wait a second. Okay, I'll show you. We will have to use either web3.js or ether.js to interact with our smart contract that we deployed. So yeah, so this is our the source code of the project, and I know it's not well optimized code and not structured well and not clean code, but it works. Okay, I'll work on the on actually making writing clean code and having more comments in the code. I'll try to improve my habit on that habit. So let's first understand what we took here. So we have ethers, which is a lab, which is a JavaScript a library. So we which we are gonna use to interact with a smart contract that we deployed. And then we have all these things like I used Bootstrap. So we have this properties, or you can say properties or objects from Bootstrap. So now we have this. Okay, this is important. This is uh, this is what is required. We when we compile this code, we need this. Okay, so you can. For my case, I wrote this smart contract over here and then compile it. So I got this artifact folder in which we have a migration file, which is this file, because it has ABI. Now, what's ABI? ABI is what we use to interact with the blockchain. So it's like kind of like API, but it's not API. It means abstract binary interface, and we have to use this to interact with the blockchain. So I will need this file. So I will have to import this in order to interact with the smart contract. So I imported this ABI over here, and then we have use state and use effect. So now I define contract address as the address of the contract that we deploy. So so when we deploy the smart contract, we obviously get an address, and I just pasted that address over here. Then we have a our app function, and then we have all these use states and use effect logic. But that's not the important part. The important part is how I interact with the blockchain. So, what MetaMask or any wallet does is whenever you open any website, it actually imports a object called Ethereum. So if I do window.ethereum, you can see I will have you can see this object, and it's not a default thing. It's here because I have MetaMask. If I uninstall this extension and everything, I won't see window.ethereum over here because it's injecting Ethereum in our every page that we visit. And so we have this. So we are gonna use this. So let's see what else we have. So what I've done is I've defined Ethereum. So we have this Ethereum as equal to window, and if no Ethereum, if we don't have Ethereum uh, from if we don't have Ethereum in window, it will console log. Uh, Make sure you have whatever it is, and if we do have it will console log this. So it's just for checking if we do have MetaMask or any wallet or not. Now the main part is this, where you connect the wallet, request account. So what we do is first we check if the wallet is connected, which actually means that if the wallet is there or not. Then we use this window.ethereum.request and await it for a method eth underscore request accounts, and it will actually um, return the account that is inside the MetaMask or any wallet. So in our case, it's this, and it will get you know uh, it will get it will be stored in this value variable eth accounts. Now we have network. So we have a network, and we window.ethereum.network version, and through which what we are gonna make sure is that we're gonna make sure that you are connected to the Rinkiby network. So this is the core, and we have network. If network is not for network is not for, and what's for is the ID, which it's the chain ID for a Rinky by test network. So if the chain ID is not 4, it's gonna alert this, and if it's 4, it's gonna run the below code. So we have all these things over here. Then we have important line of code, and which is provider. So what's provider? Provider is actually ha- what gives us the access to read from blockchain. So you can read from blockchain using provider. So we have new ethers. As we are using ethers library, so we have new ethers dot providers dot web3 provider. So in this case, we are using web3 provider. We can use any of the provider. So I am using the default web3 provider, and we are passing this window.ethereum over here because we're gonna use this window.ethereum, that Ethereum object that the MetaMask injects, and use that for as a provider. So now we have contract. You can think it like a contract. I have just wrote it over here, but it's a contract. You can declare it as contract is equal to new ethers dot contract, and we have to pass three values over here. First is the contract address. So as we define the contract address over here, we'll pass it. Then we have todo.api. So we have this file, which is the migration file. That is what we get after compiling our solidity code. Then we pass the provider, and now after doing all these things, what will get the access of the contract. So I'll just do the default changes. So this is actually contract. You can use it as, you can think it like, okay, so if I use this, I can access the contract. So now below is the code for getting the data from blockchain. So I have declared this task every transaction, which is a transaction which will be contract provider dot get task. So what is contract provider? This is the contract that we got using ethers dot pair js, and remember that we pass the provider from here inside this as an argument. Now we have contract provider dot get task. What is get task? Get task is a function on the blockchain, as I'll show you. So on the solidity smart contract that we wrote, so we have get task. So all these functions we can call them using this front end now, using this contract provider. So I can await them because I'll have to wait for them to, like, I don't want the code below it to execute until this line of code has been executed, completely executed. So I'll await, and then I'll have to even um, do one thing, that's console.log. I'll just check if it's working. Since it's gonna give us an output of array, we don't need to we didn't pass any argument because there was no requirement of any argument in the solidity code itself. So task array dot for each. This is what I did to, like, reverse. You can think of like I using it. I actually push the value of this array. Push this array. I push all these values inside this reverse array, which will, because I needed to reverse it. I could have done it here as well, but I thought can also do it here. So like I tried doing it here. There are multiple ways. So like I reverse the order of the array so that I can get the first task, the recent added task on the top and not on the bottom side. Now I update the task, which is you, which is a state. So I update task, then I console log. So I got this value, this array, reversed inside this task array now. Now I can use it to print things. Now I have another function which is add new task, that is similar. A few lines are similar, but till the provider it's same, but now we don't have this. Now we use the signer and not the provider in the contract. So when we use this contract, because we are doing some change in the blockchain, because you are calling the function which is on the blockchain, we'll have to pay some kind of gas fee and we'll have to sign the contract. So we'll need signer and not provider, and using the provider we can also get signer. So we have provider as we got here, and now we define signer as provider dot get signer, because this all code gets get signer, web provider, everything is coming from the etherjs library. So you don't need to worry about. Just remember that this is a way to this is how you use with web this etherjs library in it to get signers and providers. So I got the signer. Now in the contract, I need to pass the signer instead of the provider because I'm doing a transaction. I'll have to do a transaction where I'll have to change the I'll have to call the function which is deployed on the blockchain on the Rinkibai blockchain. So I have the contract address as it was here. I have the todo.api, which is mandatory in every case, but only change in between the reading and writing the data from blockchain is that you are gonna use provider while waiting, but when you're gonna call a function that's gonna change something on the smart contract or blockchain, then you're gonna use the signer because you'll have to sign it. Now we have a transaction, that is contract assignment dot create task. As if you remember, create task was a function that was used to create task. I pass the task and author. So these are use state. I defined them over here. So we have task and we have author, and these are use state. So I can pass it from there, and then I can await now I need to wait for this transaction to get completed. When we read from blockchain, it does not take much time. It happens in like milliseconds, but when we write on blockchain, it can take up to 15 seconds. So we'll have to wait. We'll have to wait till that happens. So we'll use dot wait here over here, and then we'll console log after it's done. And this is a function that you don't need to worry about. It's for the front end and all those React thing. So I'm just focusing on the etherjs thing over here. So now we have a function similarly like this. Everything is similar, but we are calling a different function. What we are calling is set done true and passing the ID for which I'll have to reverse the done value. So if the done value is true, it will make it false. If it's false, it will make it true. That's what it is doing. This function toggle task is doing, and it will catch if there are any errors. And here also we'll have to wait it. And here we are filtering. This is a function used to filter it. So I'm gonna filter the array, and using this thing where we're gonna match the account that the user is logged in to the account that is was used to deploy the smart contract over there. So yeah, that's pretty much how I built this my first Dapp. And yeah, that's it. Thank you for watching the video.